Hey everyone, welcome back to our channel. Today, we're diving into a crucial topic, how to protect personally identifiable information or PII and sensitive data when using the public large language models or LLMs in a retrieval augmented generation or RAG workflow. Sound complex? Don't worry, we'll break it down for you. So what exactly are we tackling today? We're exploring techniques for masking PII and sensitive data using open source libraries and regular expressions, as well as leveraging local LLMs to mask data even before it reaches a public LLM. Why are we exploring this? Protecting PII and sensitive data isn't just good practice anymore. Having worked for years helping organizations ensure they are complying with regulatory frameworks such as GDPR, for example, in Europe, HIPAA and CCPA in the US, and Privacy Act in Australia, I know that it's now a legal requirement and helps build customer trust, prevent security breaches, and reduce risks. Before we dive deeper, let's brush up some key terminology. First up, we have LlamaIndex. LlamaIndex is a leading data framework for building LLM applications. Frameworks like LlamaIndex and LangChain provide abstractions for various stages of building RAG or retrieval augmented generation applications. Next, we have Elasticsearch, a scalable data store and vector database that's excellent for full text search, vector search for semantic understanding, or hybrid search, best of both worlds. The features we're discussing today are available to you in the free and open version of Elasticsearch. And of course, retrieval augmented generation, or RAG, is an AI technique where you provide the LLMs with your specific context or knowledge, which helps it generate and tailor its responses to your user queries. This technique helps LLMs be less generic and more grounded in the context you provide. Lastly, what are embeddings? These are mathematical representations of data or text or media, which machines can leverage effectively to perform tasks like translation, sentiment analysis, and more. All right, now that we know our terms, let's discuss RAG and data protection. Typically, LLMs generate responses based on the information they're trained on, that is often sourced from the internet. But what if this model doesn't have specific information needed to answer a query? That's where RAG comes in. It retrieves relevant information from external systems like your database and sends this context to the LLM to generate a specific and useful response for you. But here's the catch. In a RAG pipeline, you risk exposing internal information such as PII and other sensitive data when transmitting data to the public LLM. Although your data is secure when using a vector database like Elasticsearch, through various levers we use like role-based access control, document-level security, etc., care must be taken when you send data outside to a public LLM. So how do we protect sensitive data? We'll discuss a few strategies to mask PII information, like using open source libraries and out-of-the-box post-processors from LlamaIndex or even your local LLMs. Sounds interesting? Let's grab a coffee and get started. Today, we're building upon our last discussion, where we explored how to implement a Q&A experience using RAG, or Retrieval Augmented Generation with Elasticsearch, as a vector database, and LlamaIndex, along with a locally running Mistral LLM. Don't worry if you missed it. We'll do a quick recap now. In our previous blog, we had a sample dataset of call center conversations between agents and customers of a fictional home insurance company. We built a simple RAG application and answered questions like, what kind of water-related issues are customers filing claims for? So during the indexing phase, we used LlamaIndex to load and index documents, chunking them and storing the embeddings in this Elasticsearch vector database. During the query phase, when a user asks a question, LlamaIndex retrieved the top case similar documents relevant to the query, and these documents, along with the query, were sent to the locally running Mistral LLM, which generated the response. In that blog, we used a local LLM. However, in a production environment, you may want to use an external LLM from companies like OpenAI, Mistral, or Anthropic for scalability and performance reasons. But introducing an external LLM comes with the risk of inadvertently leaking sensitive or PII data. Today, we'll explore how to mask PII in a RAG pipeline before sending the documents to this external LLM. Feel free to go through this previous post, which is linked here, and explore the code and make sure that you have the Elasticsearch set up as a vector database and you have your OpenAI API keys ready as well. You can clone the code from the GitHub repository, which is linked over here. And in this file, in this repository, you will see index.py, where the code related to the indexing data goes, query.py, where the configuration properties, where the code related to querying and the LLM interaction goes. And also we have this .env file where the configuration properties like the API keys, etc. go. Awesome. So the previous blog will guide you on how you can install and get your API keys, the Elastic Cloud ID, API keys. And for the second part, we'll also need the OpenAI API keys. So in the second part of the blog, we will be using the same JSON file, which is located in the GitHub repo I showed you earlier from part 1, containing the call center conversations from our fictional home insurance company. This data will be indexed using LlamaIndex, just like before, and stored in the Elasticsearch vector database. In this second part of the blog, we'll be querying with public LLM instead of local LLM. We'll use OpenAI's API to generate responses for user queries while retrieving and processing relevant documents from our Elasticsearch vector database. Additionally, and most importantly, we'll be masking PII and sensitive data before sending it to the public or external LLM. So let's jump into the code. So download the GitHub code, as I showed you, and follow the previous blog to create a new Python file. To create all the Python files which are mentioned here. And then we'll be creating this new Python virtual environment in the root folder of your application. So use this to create that virtual environment and then activate it. Next, you need to install all of these packages mentioned here. I've already done this and installed these packages, so I'm ready to run the index.python file, which takes care of indexing the data. So let me do that. And while it's doing that, let me explain what's happening here. So running the above code will basically create an index in Elasticsearch, which is called convo_index, which you can see over here. For details on how the data is indexed in Elasticsearch and LlamaIndex ingestion pipeline is used, please refer to the blog post, which I referred to earlier. This is interesting, and I'll encourage you to read that part by clicking this link here around creating ingestion pipeline, and that'll take you straight to how LlamaIndex pipeline is configured to take care of chunking, embedding, and storing the embeddings in the Elasticsearch vectors database. So indexing should have been done by now, and let me just check the progress here. Awesome, it says done running pipeline, which means that we can now go to our Elasticsearch, and when you see the hamburger menu, just click on it and go to under Nav Management, go to Dev Tools, and let's check our index. So for that, we just do a get, and then our Convo index, and we can search on that. So when we run that, we'll see all of our conversations and embeddings. Awesome, so we did that. We'll now look at our next file, which is query.py. What does this do? The above code prints the response from the OpenAI, which we're using as our public LLM. The question we asked was to summarize the water-related claims. In this query.py, unlike the previous blog post, as you can see, we are using the OpenAI's public LLM, right? And basically, this code sends the query and the context or related documents to OpenAI and prints the response here. The query engine for a given user retrieves the top 10, the top documents, similar documents from Elasticsearch vector database, and sends the documents along with this user query. Give me a summary of water-related claims that customer raised to the LLM. And note that these documents are sent as is. So any PII or sensitive data is also sent to the LLM. So let's run this code. All right, so while that is running, the above code prints the response from the OpenAI. And the question that we asked, we should be able to get answers, and that may include sensitive data. Awesome. So let's look at the response here. And it's still doing that. So I'll let it think. And after we see the response from query.python file, we'll next be moving into the most important part of this blog, which is masking our PII in our RAG pipeline. Let's see if the code has finished running. So as you can see, we can see a lot of sensitive information in the response. There's a lot of names and dates and all sorts of PII and sensitive data. Awesome. So now we will move into the crucial part, which is masking PII in our RAG pipeline. So after retrieving relevant context from our vector store, we can mask PII before sending the query and context to the external large language model. We have several options to do this. One, using the natural language processing NLP libraries like Spacey, for example. These are popular open source libraries, or you could also use Microsoft's Presidio. These can help detect and mask sensitive information. LlamaIndex's out-of-the-box processors, post-processors, also make it easier to protect PII. We can also be using local LLM's post-processor before sending it to our external service. Once you implement masking logic using any of the above ways, you can configure LlamaIndex's ingestion pipeline with a post-processor. So let's explore the option 1, which is the option of using the NLP libraries. Let's create a new Python file, query masking NLP, and then we need to install Spacey and run it, and then download the Encore web_sm package. Now add this code by clicking the button here to your file to mask sensitive data using Spacey, which will detect all of the named entities, that's what it does, and other sensitive information, and mask it before sending the documents to our OpenAI, to OpenAI LLM. So we're using the Spacey library for named entity recognition or to identify and mask PII. We also apply regular expression patterns for information like phone numbers, emails, dates, and other sensitive data. In this code, when creating the LlamaIndex query engine, we supply this post processor, this custom post processor here, which has this method, this custom post processor. This has this method called the underscore post process nodes, and which is called on the documents before they're sent to the LLM. This custom post processor masks our PII. Then, just like the previous blog, it retrieves the top similar documents from Elasticsearch Vector Store, and using the custom post processor, it ensures that the PII is masked before sending to the public LLM to print the PII-free response. Let's run this code. So again, pulling up my terminal here and running this code. And while this is running, what I'm going to do is also show you the response that will be shown. As you can see, this response and this approach does help with PII masking. However, note that identifying and masking PII and sensitive information is not a straightforward task. Covering various formats and semantics of sensitive information needs a good understanding of your domain and data. Although the code presented above may work for some use cases, you may have to modify based on your needs and testing. Let's see the response we got from the code we ran. So as you can see, we have this response and we have, for the most part, masked our PII. Okay, let's move on to the next approach, which is using LlamaIndex's out-of-the-box post-processor. LlamaIndex has made it easier for us to protect PII information in a RAG pipeline by introducing this post-processor, and let's try by copying and running this code. All right, so let me copy, and I've already copied and pasted and created the Python file, so let me go ahead and run this code. All right, so while it's running, let's discuss the code very quickly. So very similar to our last approach. In this code, we're using a Hugging Face embedding model and OpenAI LLM. We're using Elasticsearch Vector Store and applying this LlamaIndex's out-of-the-box post-processor to mask sensitive data. Then we are setting up the query engine just like before to retrieve the top similar documents from Elasticsearch Vector Store. And then the LLM is processing the relevant but PII and sensitive free documents to generate a response to the user queries. And here's a sample response that you get. Let's see when we ran the code, the response that we got as well. And yeah, you can see that we get a similar response to the one that we see here. Amazing. Let's move to approach 3. So in this third strategy, you will now be working with leveraging an LLM running locally or in your private network to do the work of PII masking before sending the data to the public LLM. We will use Mistral running on Ollama on your local machine to do the masking. So download and install Ollama by following this link. And after installing Ollama, you will have to run this code. It doesn't take very long, but it may take a few minutes if you were to download and run this model locally for the first time. And once you're done, you can just ask a question. For example, you can ask, just to test it, you can ask a question like, write a poem about the clouds, for example. And it shows its magic, and you know that it's working fine. Now create a new file called query masking local llm.py. And let's copy the code and paste it in here into the file. And I have already copied and pasted it, so I'm going to go ahead and run my file. This and run this new file. And while it's running, let's look into the code. As you can see in this code, we are using the public LLM to send the query and related documents to it, and the local LLM to mask PII. So in this, we're using a query engine for a given user query. And it does the same thing as before. It retrieves the top 10 similar documents from the Elasticsearch vector database and sends the documents along with the user query to the public LLM. And note that the documents are masked using the PII post processor provided by the local LLM, the PII node post processor in the local LLM. So this will help mask all that PII insensitive data, and it's not sent to the public LLM. Let's see the result. So the result is right here, and what we can see is similar to our previous result, which is the PII information has been masked, and all of the sensitive data is masked as well, which is great, which is what we were looking for. So well done. To sum it up, we looked at how you can protect PII and sensitive data when using public LLMs in a RAG flow. We covered multiple ways to achieve this, from using NLP libraries to leveraging Llama indexes out of the box post-processor, and also the third way of using a local large language model to mask PII. Make sure you test these approaches thoroughly to suit your specific use case. Implementing these protection strategies is crucial for maintaining compliance, user trust, data security, ethical standards, and business reputation. By understanding and applying these methods, you can harness the power of RAG workflows while safeguarding PII and sensitive data. Thank you for watching. If you found this video valuable, make sure to like and subscribe. And got any questions or thoughts? Drop them in the comments below. Until next time, stay secure and happy innovating.